in rolling without slipping, there is no relative motion between the wheel and the surface at the contact point, quite the way we consider when studying friction. So let us say you are standing on a sidewalk observing a cycle wheel as it rolls along. Well, what you see is the center of the wheel move forward at a constant speed, and let us call it V center of mass. And the other point you should observe is point P on the road, where the wheel makes contact with the road surface. And this also moves forward at V center of mass. After all, it has to, if the entire wheel has to move forward as one single unit. Now, consider a time interval t in which you can see that both O and P move ahead by a distance s. And the rider can see the wheel rotate through an arc, and let us say the angle of movement is theta. And as a result, point P that was touching the road at t equal to 0 seconds should also have moved through an arc length s. Then simple geometry tells us that s is equal to theta r, where of course theta is in radians and r is the radius of the wheel. So now let us go ahead and differentiate this equation with respect to time t, and what we get is ds upon dt is equal to d theta upon dt into r. But then we know that linear speed of the center of the wheel is ds upon dt, and also the angular speed omega of the wheel about its center is d theta upon dt. And so we can rewrite this equation as V center of mass, that is this part, is equal to omega r. Now this relationship is very important because this ensures the condition for rolling without slipping. That is, if for a situation where an object is rolling and you're told that for this object the equation V center of mass is equal to omega r is true, you can safely say that the object is rolling without slipping. Or you can also say that there is no relative motion between the surface and the object. Or in simpler words, you could say there is no skidding.